We're really at this major turning point where AI is shifting from being just a tool to becoming a truly autonomous partner. This is the new era of agentic AI. So today we're going to break down how these systems are actually engineered, how we can watch them work, and maybe most importantly, how we keep them on the right track.
And this quote from Microsoft's Satya Nadella, it just hits the nail on the head, right? The real story here isn't about replacement, it's about augmentation. The whole idea is to let AI handle the repetitive grunt work, which frees up engineers like us for the more creative, high-value challenges. That's really the core idea we're going to keep coming back to.
Okay, so here's our roadmap. First, we'll kick things off with the fundamentals. What's the actual difference between a simple bot and a true agent? Then, we're going to pop the hood and look at an agent's brain, see how they're built, figure out how to watch them in action, and finally, we'll tackle the big one. How do we build the guardrails to make sure they're safe? All right, let's jump right in. What actually makes an AI agentic? It's way more than just a cool buzzword. It's a massive leap forward from the kind of automation we're used to. This slide really breaks it down perfectly. On one side, you've got traditional automation. Think of it like a script. It's rigid, it's predictable, it does exactly what you tell it to. But on the other side, you have agentic AI. This is where things get interesting. It can make its own decisions. It uses the incredible reasoning power of a large language model, an LLM, to adapt on the fly. It's really the difference between a calculator and a genuine problem-solving partner.
So what's actually going on under the hood? Let's break down the 3 core capabilities that give these agents their power to act on their own.
Everything starts with planning. So you give an agent a big, high-level goal, like plan a new marketing campaign. Its first move isn't to just start writing. Nope. Its first job is to break that huge task down into a series of smaller, logical steps. This becomes its entire strategic blueprint.
Next up is memory. This is what gives an agent context and stops every conversation from feeling like you're starting from scratch. Short-term memory is like its working notepad, tracking the current task. But long-term memory is its library. It recalls past conversations, learns your preferences, and gets smarter over time.
And finally, we have tool use. Now, this is how an agent actually does stuff in the real world. A language model, by itself, can't book a flight or run a data analysis. Tool use is what lets it call an airline's API to check for flights, or execute a piece of code to get you the numbers you need. It's the critical bridge between thinking and actually doing.
So how do these 3 pieces, planning, memory, and tool use, all come together? Well, a really popular pattern is the REACT framework, which is just a simple way of saying reason and act. The agent has a thought about what it needs to do. Then it takes an action using one of its tools. Then it makes an observation of the result. That observation then feeds right back into its next thought. It's this continuous loop that drives the agent forward. Okay, so we've got a handle on what an agent is. Now let's get into the fun stuff. How do you actually build one? Especially when you need a whole team of them working together. This is where frameworks and design patterns are absolutely key. Man, the tooling ecosystem for this stuff is moving at lightning speed. This table gives you a quick snapshot of some of the big players. Frameworks like LangGraph and CrewAI are what we call goal-based. You give them an objective and they work backwards to figure out the steps. LangGraph is awesome for building these really robust, auditable workflows that big companies need. CrewAI is fantastic for coordinating whole teams of agents working in parallel. And then you have AutoGen, which can be reflex-based, making it perfect for building those complex, back-and-forth conversational AIs.
And underneath all these fancy frameworks, developers are using a pretty common set of design patterns. Think of these like Lego bricks for building sophisticated AI systems. For example, a router acts like a traffic cop. It sees a financial question and sends it to your finance agent. One of the coolest patterns, though, is the evaluator loop. This lets an agent literally check its own work, spot mistakes, and then go back and fix them. It's self-correction in real time.
All right, this next part is absolutely critical.
Once you've built this amazing autonomous system, you have to be able to see what it's doing, and more importantly, why it's doing it. This is what we call observability.
And this really is the million-dollar question, isn't it? With regular software, if something breaks, you can trace it back to a specific line of code. But with an AI agent, the logic is this complex web of reasoning inside the model. So when it messes up, where do you even begin to look?
This diagram really helps visualize the challenge. A user's input goes into the system, something magical happens in that LLM processing box, and an output comes out. But what exactly is going on inside that box? Without the right tools, it's a complete black box. And that's not just a debugging nightmare, it's a massive security risk. So to crack open that black box, you need a whole new level of observability. It's not enough to just track inputs and outputs anymore. You have to capture the reasoning logs. That's the agent's internal monologue, its step-by-step thought process. You need to trace every single tool the agent uses and every API it calls. This is how you turn that scary black box into a transparent glass box.
And that leads us to our final and honestly, probably the most important section of all. With all of this autonomy and power comes a whole lot of risk. So how do we build the guardrails to make sure these agents operate safely and ethically?
And let's be really clear, the stakes here are incredibly high. An agent could have access to sensitive customer data, financial systems, you name it. A mistake isn't just a software bug anymore. It could be a major data breach or a really costly business blunder.
This slide makes a really key point. Security is a shared responsibility. It's not just on one group. The AI providers, the folks building the foundation models, have a huge role to play in filtering harmful content and anonymizing data. But the deployers, the people like us who are building applications with these agents, we're on the front lines, responsible for how they're used and for making sure our users are educated.
So for anyone actually deploying these agents, here are a few absolutely critical strategies. A human in the loop is non-negotiable. You always need a person to sign off on high-stakes decisions. And classic but crucial concept, the principle of least privilege. Basically, if an agent doesn't absolutely need access to a tool or a database, don't give it access. Simple guardrails like these are essential before you let an agent loose in the real world.
So, let's bring this all back to where we started. This technology is fundamentally changing what it means to be a software engineer. The job is becoming less about writing every single line of code and way more about being an architect, designing the systems, defining the requirements, and guiding the AI to the right solution.
So I'm going to leave you with this final thought. This isn't science fiction. It's not coming in 5 years. It's happening right now. Agentic AI is a massive shift, a tidal wave of change. So the question for all of us isn't if this is going to change our jobs. The real question is, how are you going to adapt your skills to lead the way in this new world of intelligence systems?